Okay, so it's a Voronoi diagram. We're given a lot of information. Part A, show the equation of the perpendicular bisector. Okay, this is a classic question. You just have to go through the steps. Alright, so let's have a little look. Part A, let's see what we need. The perpendicular bisector of CD. Okay, C and D. First of all, let's list the coordinates. C is at 7, 2. D is at 4, 1. Let's go through the steps. I'll split this in half. Okay, step 1. Midpoint. There is a midpoint formula, so the midpoint is going to be here, obviously right between them. And the idea is that the midpoint is going to allow us to find one point on the perpendicular bisector. And the perpendicular bisector, by the way, is in fact this line. So we're trying to find the equation of this line, so that might help us in terms of the orientation and the gradient. So we're trying to find the gradient of the blue, but we're going to work on the red line to start with. So midpoint is we add together the x coordinates and then we add together the y coordinates, and then we find the average. This is formula given in the formula book. 7 plus 4 divided by 2 is the x coordinate, and the y coordinate 2 plus 1 divided by 2. This is m, the midpoint, and the midpoint is at 5.5, comma 2 plus 1 is 3 divided by 2 is 1.5. So that's this guy here. So this guy here on the diagram is 5.5, 1.5, and that fits really, doesn't it, with the diagram we've got. Okay, 2, we want the gradient of CD. Now gradient of CD is rise over run, and rise is how much the gradient rises, the line rises. The difference here is 1, and across is 7 and 4 is 3. Of course, you can always draw on your nice little triangle on here, so you can draw a triangle here, right? And you can physically see the rise and the run, right? 1 divided by 3. That's great, that's the gradient, 1/3. And then we've pretty much done with CD. We now need to switch to the blue. So let's switch to the blue. And now for the blue line, oh, I'm still on my straight lines. So look, on the blue line, now the blue equals the perpendicular bisector of CD, right? So now let's have a look. The gradient of the blue, well, we go back to the gradient of the red, and it's a negative flip, right? We flip around the 3 and the 1, we make it a negative, and again you can confirm that by actually counting some of the squares there, but that's the link. And now we go ahead and we use y equals mx plus b, and then just think about everything we can substitute into there. We've already got the gradient that can go here, so we can write y equals minus 3x plus b, and then we have to find the magic plus b, and to do that we substitute in, right? We grab x is 5.5 and y is 1.5, and we substitute in and rearrange to find b. So let's go ahead and do that. We have 1.5 equals negative 3x plus 5.5, sorry, my bad. Oh, my bad. So I wasn't really thinking what I was doing. My mind's drifting off, so we can make mistakes easily. We switch off. Remember I said I'm going to substitute 5.5 in place of the x. So it's minus 3 times by the 5.5, and then plus the b. Now, simple algebra. This is negative, it goes across, it becomes positive, or you can end solve. 1.5 plus 3 times 5.5 equals the b. Switch to my calculator just to make sure I get that correct. And that's 1.5 plus 3 times 5.5, and that gives me the 18. That's looking good. And look, here's my equation. My equation for the perpendicular bisector is y equals minus 3x plus b. But we've just found that b is 18, so therefore we have found indeed the equation, and we've got it to be the same thing as we wanted here. Alright then, now let's look at b. Complete the Voronoi diagram above. Oh, sorry, I wasn't showing my screen there, look. So I found the equation at the end. We're on part B now. Complete the Voronoi diagram above. So the Voronoi diagram takes every pair of points and finds the perpendicular bisector between the two. Okay, so I think it's maybe staring at us that there is no perpendicular bisector between A and D. So basically we want to find the halfway between them. We want to find the midpoint. 4 plus 1 is 5, divided by 2 is 2.5. So we want to draw a vertical line at 2.5, and that will complete the Voronoi diagram, right? And it stops where it joins the others, and you can see that it hits beautifully at the junction of two other perpendicular bisectors, right? There's always 3 perpendicular bisectors hitting at one of these tasty little vertices. And finally, let's have a look at this last one. We might need a new page for this. And Annie opens an office equidistant from 3 of the cafes B, C, D. Well, you can kind of see, can't you? Look, B, C, D, equidistance is that point there, that vertex. So the equation of the perpendicular bisector of BC. All right, so let's have a look. BC, the perpendicular bisector, is this guy. So this line has an equation of 3y equals 2x minus 1.5. Brilliant. But then we've also got, of course, the equation of the perpendicular bisector, which we've just shown. And this line is indeed this equation. So we basically want to find where those two lines intersect each other. Now you can do fancy algebra, but these are both linear equations, they're straight lines. So we can go straight to our calculator again. And we're going to solve simultaneous equations. Menu, algebra, solve system of linear equations. There are 2 equations there with x and y in. Go ahead and just type in the equations. I've got 3y equals 2x minus 1.5. I'm going to press tab to go down to the next line, and this is y equals negative 3x plus 18. Boom. So the actual coordinates here, it's getting a bit messy here, apologies. See, the x coordinate is 5.05, and the y coordinate is 2.86. So that's the coordinates of this little vertex here, and it seems to fit with the numbers given on the picture.